Morning everyone, welcome to this session number 401, and today I will continue with this problem. I think that I am very close to solve. One moment, I want to share this transmission in X. Okay, nice. Okay, got it. And okay, this is the problem. A is the meeting rooms, and essentially is that we need to determine how many what is the minimum number of room meetings that I need to satisfy all the meetings that I have in this list. Yeah, and yesterday I was following an idea that in this moment I don't remember. What is the idea? Okay. In this case, is sorted. Is sorted by the start. Start time. In this case, 0, 0, 1, 5, 8, 11, 14, and 15. And okay, I need to and I need to remove all the time. Yeah, let me remember. Okay. For example, if I have this array, yeah, the first is sort using the start as a reference. Okay, this is the first point. Now the next that is in this point I don't know if is have a few lists that every list represent a room, but well, in this case, for example, the first is this 0 and 30, where it's empty. In essential, I is only add here, and that's it. Okay, now it's moved to the next. In this case, for example, is 0. Yeah, it's taking this where 0 is greater than the final, means that this can replace this. In this case, for example, 0 is minor than, no, 0 is greater than 30, no, okay, means that I need another room for copy this. Okay, now move with the next is this, and now is 1, is basically start should be greater than finish or end. Yeah, in this case 1 is greater than 30, no. 1 is greater than 2, no. Okay, in this case means that I need another meeting room. Yeah, and move with the next. Okay, now the next that is this is 5 is greater than 30, no, is greater than 2. Yeah, in this case is greater. Okay, in this moment this don't make sense continue in the list, because in this moment, for example, if the time to start is the 5, means that this meeting was complete. Yeah, for example, if you, yeah, exactly, it's exactly in the real life. If you have a meeting at the 5 p.m., don't make sense continue with this register, because this meeting was completed 3 hours before. Yeah, it's the same. In this case, this is the lead, and now this is here. Okay, and that's it. Now moving with the next is this, is 8 is greater than 30, no, is greater than 10, no, is greater than 7, yeah. Okay, in this moment this is removed, and now this is the new current meeting, yeah. Now the next that the time is 11 is greater than 30, no, is greater than 10. In this case, for example, is greater than about, yeah. Okay, for example, in this case is this is removed and is put here. Here I have my dough. For example, in this case 11 was great to the previous, that is this. I replace it. And what is the next? Continue with the others, but don't insert and only remove if this is greater. For example, in this case is greater, I can remove. I don't add again because was add before, yeah, and this is complete. I think that this is the idea. Okay, now the next step is this, is 40 is greater than 30, no, is greater than this, no, are equal, but it's not greater. Okay, means that I need another register here. Okay, now the next that is this, 15 is greater than this, no, is greater than this, yeah. Okay, in this case I can remove this element and insert the new here and continue with the others. Is greater than this, no. Okay, and it's complete. Now we have the register of 3. Okay, in this case I think that it's not necessary have a list, because in essential all the time you only have one element all the time, one element, one element. Okay, I think that it's enough only with the indices. For example, 0 and 30 is the index 0, 15 and 20. What is this? This is this 0, 1, 2, 3, 4, 5, 6, 7 is the 7, and the next that is 14 and 29. 14 is the 6, and only have the reference. I think that I can use the heap, the min heap. I think that the min heap, and if I sort this element with the min heap using the n as a parameter, means that this is the real order. Okay, and where, for example, I find one element is compared with the first ending, if it's not inside here. For example, here, do you imagine that we have another 18 and I don't know, 27, sorry, 27. Okay, now is 18, sorry, 18 is greater than the mean. In this case is this, no, don't make sense continue, because the other are greater, yeah. In this moment I can discard. For example, in this case I change the 18 by 27, no, 30, for example. Okay, now this is here, 30 is greater than this, yeah. Okay, I can remove and add this element here. Now the next that is this is greater than this, yeah, in this case is removed, and don't add because was add before. Now the next is with this, no, okay, it's ignored, and now in this moment I only have 2 registers. Makes sense? I don't know if makes sense this idea, but at least for me, yeah. Okay, now how okay, sorry. Now it's time to implement. Okay, the first is sort. Sort these elements. This case is erase dot sort interval. Oh, let me remember. Okay, this is a lambda, and now it is integer dot compare int. It's compare only. Compare, and in this case, do you remember that is a matrix? Means that is A in the position. I am sorting using the star. Okay, is the 0, and B is the 0 2. Okay, okay. Now I have solved this. Now the next that. Is create the heap with a priority queue. In this case is an integer. Okay, let me check. Min heap equal new, come on, new priority queue. But in this case I need to sort the elements by the end time, but I think that here I forget how to implement this. Is with comparator. I forget. Let me check. I learned this in the course. In heaps. Where is no. It's here. Okay, it's similar with the lambda. A comma b lambda, and here is okay, accessing to the interval in the position A. And in the position, yeah, is the in the position 4, and now is with the end time, and with the end time in this case is 1. And here I think that I can use the integer comparate. This comma the other, but with the letter B that represent the other parameter. And now this is complete, and this is complete too. Okay, now I have this. The next is iterate over the intervals that in this moment are sorted. Integer interval intervals. Okay. No, I think that here I need the index I is equal 0, because I am adding, I use the priority queue with the index, with this index. I think that is much better if I use this way. Intervals dot length I plus plus and now I iterate. In this case, for example, I have even in this order I receive the first, that in this case if the min heap is empty, it's only add min heap dot add and is the index, yeah, for add this index here and continue, don't do anything. Yeah, now in this moment I have in the priority queue the priority queue have the index 0. That index 0 is this. Okay, now the next is this. In this case is empty. No, okay, you can continue. What is the next? The next that is compare this with the minimum. I need iterate over the min heap. Sorry, I forget. It's with a while. Pretty Q operation. I think that is with remove or with pick. Forget the minimum value and continue. Here is meanwhile min heap dot peak. In this case, the peak is the minimum number using the end. In this case, is the only number is this. In the position, because it's an array. No, but this is a position. Is intervals in the position this in the index 1, that is the end, is minor that intervals in the position I with a 0. In essential, this is the, for example, if I am, this is the array, I am saying that 0, or following this idea, is that intervals in the position, for example, 0, yeah, the end, that is 30, is minor that the new interval in start, yeah, this is minor that this, in this case, is not. But where it's true is in essential only remove, yeah, and is min heap that remove and continue, and only and the final is min heap dot add, and is the new interval. In this case, the interval is I. And it's only return the size of this element, I think. Oh, sure. And I need validate that this is not empty. Oh, okay. Okay, it's a good signal. Okay, now a few tests. Okay. Oh, no, 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 no. Oh, come on. I have the question that for meeting, if I change the question, now you have 4 rooms in the series of the meeting. What? I output 5. Okay, maybe it's for the equal. Let me check. Uh-huh. Because where is complete, I can remove because it's the time to switch and continue with the others. Okay, let me check if we have more tests. Okay, no. Cross fingers. Ah, damn. Okay, what is the error here? I output 1. Is for the equal. I'm sure that is for the equal. Mm-hmm. Okay, here I need to fix something here. Because for example, in this case, if I sort these elements here, the first is, well, this is the last. And is first is this and ending in this point. Now the next that is this is a second room. Now the next is this. This is removed because it was complete. And this end in the same time that this. For this reason, this should be returned 2. But with this case, what is the problem with this case? Okay, if I sort these elements, is 1, 2, 3, 4, 5, 6, 7, 8. Is are sorted. Now is 5 and 2. Now is 2 and 6 are in need 2 rooms. Now is this 3 rooms. 4. 5. In this case, where this start. This is ending. Where this start. Okay, in this case, I think I need to check if I am using the. I think that is right. The pop is pop. No, is remove. I'm using remove. The other is pull. I don't see the error. I know what or what is the reason, but this 1, 2, 3, and 4 meeting rooms, but where this start, this is ending. Okay, I think that in this case, I am thinking that maybe it's not necessary handle this as an arrays like this, because in essential I am only using the end time to do it. In this case, I think that I can use in this way, and only here use the intervals in the position 1, that is the end, and all of them only use this. And here instead they save the position, it's only intervals in the position I in the with the end. Sorry, this is I. Okay, it's still in the same, but it's much better. This is more clear. What is Why? Is sort by the first element. Overflow comparators. Oh. No, but this is for integer comparate 0. No, I don't think that this is right because you're solving the other cases, but in this case this is not. But it counts for this. Okay. I sort the elements. Next I create a pretty queue with the main heap. Where is empty is only add and continue with the other. No, even in this case it's not necessary this. I can remove it and only have this. It's exactly the same what with leetcode. Let me sort these elements. Should we have the same result? In this case I start with this and this. Now the next that is this, it need another room. Now the next that is this. I remove this and I remove this. Or what happens if I add a new element here that is 16 to 17? I think that is for the finals. Let me check. This star. Now the next that is this. Need another room. Now the next thing is this. This remove this and only have this. Yeah, and now is this. That this remove this because was complete. Yeah. Why I need two elements? Well, this is frustrating that the problem doesn't define if the n and interval is inclusive or exclusive of the n. Unclear if 1 and 2, 2 and 3 requires 1 or 2 meetings rooms. It's not clear, for example. Yeah, but what is the answer? I have, for example, this. If I sort is 1 in 30, and the other is between 30 and 15. This counts as non-overlapping. It should be present as a 1. For example, this, the result should be have 1. For example, if we have meetings like 1 5, is this? No, is this 1 5 3 6? The output should be 1 5 5 9 to 6 6 10. Okay, the home one. 1 5 5 9, but in this moment is not overlapping. Yeah, this replace this. Now this replace this, this replace this. Yeah, it's equal. Why in this case is not? Okay, now, okay, for example, I sort this using the first parameter. Okay, now I have a pretty queue here with the n times. Okay, now the first that is this 1 30. Okay, is empty. I save this value. Well, whatever. The end here. Okay, now this is the minimum number. Okay, now this is complete. The next that is this 6, 9. 6 is greater than the minimum. No, means that I need another room. Okay, in this case I save the 9 here, and now the minimum. Do you imagine that the minimum is the element that in the bottom? Okay, here in. Okay, got it. Now this is complete. The next that is 13 and 15. This is greater equal that this, yeah, okay, is removed. Now 13 is greater equal this, yeah, okay, is removed. Now is empty, and now we can add the 13 here, and this is complete. Now the next that is 16 and 17. No, sorry. I'll be back. This is greater than 13, yeah, and it saved the 15. Okay, and this is complete. Now is 16 is greater than the minimum, yeah, okay, this is removed, and now we only have 16. I return 1. Why expect 2? Okay, let me check. Yeah, but don't have more details. Well, it's the last year. Yeah, I have the same though. In which moment is inclusive and which another moment is not inclusive. Yeah. What if a previous interval n is equal to the next star interval? Will it be considered as an overlap? There must be the test case. Yeah, I have the same though, but my solution don't resolve both problems. If I use this, mm, ah, and why with this? The answer is 1. Okay. In this case we have the first that is this. I save the 15. No. Is the first is this because it's sorting using this. Okay, the first element is 1. Well, this, and the n is this. Okay, 13. Now the next that is 13 and 15. This is greater equal this. Okay, this remove it, and I only add this here. That is 15 and is complete. Is the answer is 1. But why here is I have the doubt why here with this is don't apply the same rule because why return true? Okay, I will put this. Why spec 2 instead 1? And is a question. The preview. Okay, I will save this question because I really don't want to check the answer. But I have though I don't know why works with this and is overlapping where is including the end and the start. If have the same, I can remove it, but why with the other works and only with this case it doesn't work. But well, I think that it's enough for this session, but thanks for following this transmission, and I hope see you in the next. Bye bye.